Every time you get behind the wheel, you're commanding this incredible, hidden marvel of engineering. We're talking about power steering, the system that lets you turn a 2-ton hunk of metal with just a light touch. Today, we're going to pop the hood and really see how this thing works.
And isn't that the absolute truth? 1 second you're gliding into a tight parking spot with one hand, and the next, if it fails, wow. The steering wheel suddenly fights back, and you realize just how much heavy lifting that system has been doing for you all along.
So that's the big question, right? How does that happen? It's definitely not magic. It's this brilliant mix of physics and some really clever design. Let's break down how we went from wrestling with the wheel to steering with our fingertips.
Okay, so before we can even add the power to power steering, we have to understand the problem we're trying to solve. What are we actually fighting against every time we turn that wheel? Let's look at the raw mechanics first.
Think about all these invisible forces at play. You're not just turning a wheel. You are fighting the sticky friction of your tires grinding against the pavement. You're fighting the entire weight of the car pressing down. Plus, you've got the complex geometry of the suspension and all the resistance in the mechanical parts. It really is a battle of forces.
All right, so here's the basic mechanical chain of command in most cars today. You turn the wheel, right? That spins a little gear called a pinion. That pinion then pushes on a long bar with teeth, that's the rack, moving it left or right. And the rack is connected to your wheels. It's actually a beautifully simple way to turn your rotational motion into a side-to-side motion. Now, here's our first bit of help, good old-fashioned mechanical advantage. A 15-to-1 ratio means the system is already multiplying your effort. But as cars got bigger, heavier, and tires got wider, that multiplication just wasn't enough. The wrestling match was still on. We needed a new kind of muscle.
And for decades, the answer was hydraulics. The idea was pretty simple, really. Use a pressurized fluid to do all the heavy lifting for you. This was the go-to technology from the 1950s all the way into the 2000s.
So this is your basic hydraulic toolkit. You've got a pump run by the engine that creates pressure. That high-pressure fluid is just waiting, ready to be sent through hoses to a piston that can push that steering rack with incredible force. The real question is, how does it know when to push, and just as important, how hard to push? Well, the secret is this little piece of genius right here, the torsion bar. It's a small rod that sits between your steering wheel and the pinion gear. When you turn the wheel, this bar actually twists, just a tiny amount, and that little twist, that's the key to the whole system. It's basically a mechanical torque sensor.
And here's where it gets really clever. The whole system is proportional. If you turn the wheel gently, the torsion bar twists just a little, opening a valve just a crack and giving you a bit of help. But if you really crank on the wheel to get out of a tight spot, the bar twists more, the valve opens wide, and you get a massive surge of hydraulic power. Your effort directly controls how much help you get. It's brilliant.
And the kind of power we're talking about here is just incredible. Get this. With fluid pressure at around 1,200 psi pushing on a 3-square-inch piston, that's 3,600 pounds of force helping you move that steering rack. That is the hidden muscle that makes parking a giant SUV feel completely effortless.
But hydraulic systems had a big core flaw. That engine-driven pump was always running. It was always spinning, always burning fuel, even when you were just driving in a straight line down the highway. It was super inefficient, and that wastefulness paved the way for something smarter, cleaner, and way more efficient, the electric revolution.
The core difference is simple, but it's profound. Instead of a pump that's constantly sucking power from the engine, electric power steering, or EPS, uses an electric motor that only draws power when you're actually turning the wheel. The efficiency gain is massive, and it's exactly why EPS is in pretty much every new car today.
So the components are different, but the principle is basically the same. An electronic torque sensor replaces the old torsion bar, a little computer module replaces the hydraulic valve, and a powerful electric motor provides the muscle. No more pumps, no more fluid, no more leaky hoses. It's just a much cleaner, more elegant system all around.
And here's one of the biggest wins of going electric. The computer can change the amount of help it gives you based on your speed. When you're going slow, like in a parking lot, you get maximum power for easy one-finger turning. But when you get on the highway, it backs off the assist, making the steering feel firmer, more stable, and a lot safer.
This brings us to a more subtle but absolutely critical part of the story. See, power steering isn't just about making things easy, it's about engineering the perfect feel, that sense of connection between your hands and what the tires are doing on the road.
It all comes down to finding that perfect balance. If you have too much power assist, the steering feels numb and disconnected, almost like a video game. But if you don't have enough, it just feels like a workout. With modern electric steering, engineers can literally tune this feeling with software, dialing in the perfect amount of feedback for any car in any situation.
And that software control, it's about so much more than just feel. The move to electric power steering wasn't just an improvement, it was a gateway technology. It unlocked the entire future of driving as we know it today.
I mean, you can see the whole progression right here. We went from pure muscle to hydraulic muscle to the smart, efficient electric muscle we have today. And that final step, that's the one that makes all of our modern driver aids even possible.
Think about it for a second. For a car to keep itself in a lane or parallel park itself, the car's computer has to be able to physically control the steering. That's just impossible with a purely hydraulic system. But with EPS, the computer can send a tiny signal to that electric motor and turn the wheels with pinpoint precision. EPS is the foundation for almost every modern driver assist feature out there.
Ultimately, that's what this is all about. Whether it's using hydraulic fluid or an electric motor, it's this beautifully complex, carefully controlled system designed to create a seamless, powerful connection between you and your vehicle.
So, the next time you effortlessly turn a corner, just take a second to remember the incredible journey of innovation that's happening right there in your hands. It really makes you wonder, what other everyday things are we taking for granted that are far more complex and clever than they appear?